Hey guys, Nick Eilerman here. Today we're going to go through the electrical system of my Ford camper van. We're going to go ahead and start with the front and try to keep this video nice and concise, and then hopefully at the end we can show you guys a little drawing of these schematics. So let's go ahead and start here in the front of the Ford Transit. So on Ford Transits, underneath the driver's seat, we have 1 or 2 batteries. So my version of this van, this is 2019, low roof Ford Transit 150. There's only 1 battery in here. So it's an AGM battery. And what I've done is I've got 2 wires coming off of here. We got our positive and then we have our negative wire. And so what we're going to do is we're going to go ahead and we're going to take the positive wire and we're going to run it to our breakers here. So in any van power system, you're going to want to make sure you have appropriately sized breakers for the amount of power that you're moving through the system. And actually, more specifically, it has to do with the gauge of wire that is transferring that power to whatever destination or device that you're sending it to. So for example, let's move into here. So we got two breakers right here. This breaker right here is going to be an 80 amp, and this one right here is going to be a 60 amp. So this one right here, you can see that this is disconnected. So this is actually not going anywhere. So if I turn this on, this terminal is not going anywhere. So if we undo it, this used to go to a dedicated DC to DC charger that was right here on this wall. A DC to DC charger is exactly what it says. It's taking the direct current from the battery, and then it is managing that current down to a certain amperage to charge your house battery. So our coach battery, I'm sorry. So the battery right here that would be running your van accessories. So depending on the type of battery you have, whether it's lead acid, AGM, or lithium iron phosphate, whatever that chemistry is, you're going to want to make sure that your DC to DC charger can handle that. What's nice is when your car is running and the alternator is running, this circuit right here, this circuit I have, that is what fed power to my DC to DC charger. So I removed that, and so I'm not using that anymore. But over here, I do have this breaker that is going directly to my battery now. So this positive line is going directly underneath the floor, all the way around here, under here, and comes out right here at the battery disconnect. So that line is coming out right down here to the battery disconnect. And then the battery disconnect is feeding power to the battery, and then it is going to the inverter. So if I come back over here, this is what we're using now as our charging device. So we don't have a DC to DC, but we do have charging our battery. So the power that's going here, if you go feed, just watch the track. It goes all the way back, and it's coming from our PWM solar panel charge controller. So a PWM stands for pulse width modulation. It's a cheaper type of charge controller for solar panels. In this van, I have 100 amp hour battery, 200 watts of solar on the roof. It's a very simple, easy to use system. Very basic, but great for a weekender trip. And So I just installed this because it's very cheap. I mean, you can get these on Amazon, 80 bucks, something like that. And it does support the lithium chemistry. So what you do is you click this button, you cycle through whatever chemistry your battery is, and then it's blue, so that means it's for lithium right now. The green light indicates that we do have we are connected to our battery, and then PV is photovoltaic. That is sensing that we do have power coming from our solar panels. I believe since it's flashing, that means that we're at 100% charge, which is true. So if we go right here, we are at 100% on our, I don't know if you can see that, that's strange. Anyway, we're at 100% on our charge. And so that was blinking right there. So now what this is doing is there's two inputs right here. So these two inputs are coming from the roof. One's positive, one's negative. Now this is fused up at the solar panel. So there's an inline fuse in between the solar connectors up on the roof of the van. You won't be able to see that. I can't show it to you. It's actually zip tied underneath the solar panel. And that is just in case something happens, there's a dead short up at the solar panels and it will break there. But if it doesn't, power comes into here. This is our negative bus bar, which is connected to our engine battery and this to complete that circuit. And then we have the positive output that is charging our battery. This is not necessary. The reason that this is here is because I took a 4-gauge wire and I'm just using this to crimp it down and come out as a smaller gauge wire to go into this box. This was too thick to, crimp down and go over there. So this is basically just to adapt my 2 gauges of wire. So this is not necessary. You don't have to have this in your system. All you would need to do is properly size this cable to go into here. The reason that my setup looks like this is because I used to have this going into a DC to DC charger that had a solar panel input option. So all that, we're going to move back to the back. So that is how that works. We have solar that comes in, goes into the charge controller. Charge controller puts the power into this positive line. It goes through this breaker, which is appropriately sized for the amount of power and the gauge of this wire. And then so we got a 6-gauge wire going all the way through our floor. And when you design systems, you want to make sure you're always able to access it. So if you look under here, we're able to access this wire. It goes all the way up into our battery just in case anything happens or we need to get to it. And this is our little storage area. But yeah, before we close in this floor right here with maybe some angle iron or something like that, you just want to make sure that if you have any problems that you can go ahead and fix those problems. The cables you can see here, just wanted to show you them. You got a couple things that come with solar charge controller kits or DC to DC chargers. You may have a display that shows you your voltage. You can also have, this system is by Renogy. This is their BT2 Bluetooth adapter. So this will allow you to have a readout of how your solar charge controller is working. This one went to my old DC to DC system, so this one is actually not connected. This one's not connected to this because this is more of an old school. So if you wanted to use the Wanderer from Renogy, you would need to buy the BT1, not the BT2. So this went to a different unit, and I still need to take that out. But keeping on with the video, we got our solar charge controller. We're moving down. And now our power is going into disconnect here. So the way I had this disconnect working is we have a 2-aught wire that is going to our battery over here. And then from our battery, we have, we're using our Megafuse initial terminal right here. It's just like a bus bar terminal, essentially. So that might be confusing for, let me turn this light back on. Get you guys some more light in here. There we go. So essentially what we have is we have the power comes in here. So this is our power in lead from our solar charge controller. And then this is our connection to the battery disconnect right here. And then our battery disconnect is going to the battery. So if we needed to shut the battery off for any reason, we would shut it off here. Now what that means is this line would also need to be shut off behind the driver's seat where the solar power is coming in, because this is the breaker is closest to where the power is coming in. So this is the end of the line, so there is no breaker here. So if you wanted to completely disconnect the solar panels from the system, you would have to do that at the front. You can disconnect everything from the battery here, but up where the breaker is, that's where you would need to disconnect the solar power. So when the system is turned on, so we got our battery disconnect on, there's one very, very, very important thing to note is your solar charge controller always needs to be connected to a battery when voltage is being passed across the system. What that means is the solar panels up top. Let's just pop up here so you guys kind of keep with the story. So these solar panels, they're always on. What that means is if you're outside, it doesn't matter what you're doing. These solar panels are converting power from the sun. And the only way to disconnect these solar panels is to disconnect them at the breaker level. Why this is important is if you don't disconnect them at the breaker level over here, power will still be running in this type of setup to the inverter. So this will still have voltage coming through it, regardless if you disconnect your battery disconnector, because your battery disconnect is to protect your battery and your battery alone. So this is only for the battery. You do need a secondary system to disconnect your solar panels. That's really important. What's also really important is most charge controllers, DC to DC chargers that have a integrated solar panel power input, it's really important to make sure that you are disconnecting the solar power going into it prior to disconnecting the battery. You want the battery to be the last point of disconnect when you're servicing a system, because you can damage charge controllers if you disconnect the battery before disconnecting the charge controller coming in, because there's nowhere for the power to go once you disconnect the battery. So disconnect the solar panels first, then disconnect your battery when servicing your system. That way you will not damage the circuitry, because again, solar panels are always on, so you need to control that voltage to not damage any devices, if that makes sense. Okay, moving on in, we have our we have our power. We have it controlled to make sure that the solar charge controller is providing the correct power to adequately charge the battery system. And so what that charge controller is doing is providing a specific voltage that a certain battery chemistry likes to be able to charge. So lithium batteries like a little bit of a higher voltage, and AGM batteries, lead acid, are a little bit lower. It's not a massive amount of difference, but long story short, they're different voltages, and it creates a better environment for them to charge. You can check out your battery's requirements online, so you just look at the manufacturer, and they will tell you if there's a specific charge profile that is required. Now, when we were talking about this charge controller over here, if you remember, each one of these chemistries has a different profile. That's what I'm talking about. So now that we have the correct profile chosen, we know that the power coming out of our, whether it's a DC to DC charger or a solar charge controller, is correct. So now that we know that's right, we have a breaker, we have a disconnect, our power coming into our system is safe. So now what's going to happen is that power, we need to distribute that power to our systems. So we have two systems that we're doing, two ways that we're consuming power in this van. The first is we have our direct current, which is up here. And then down here, this is what will create our alternating current. And we're doing that by powering this inverter. So this is a 2,000 watt pure sine wave inverter. We'll get to the inverter details here in just a second, but just want to begin with there's two different methods of distributing power in a system. This could be marine or your van. So what we've done here is usually you would have, depending on the complexity of your system, this would actually be its own distribution plant bar or bus bar, where these three wires right here will be connected on a bar, much like this. But for my purposes, I don't really have a complicated system because we have our solar input, we have our battery input, and then we have our distribution to the 12 volt. So it's nice and simple, and we can do this all on one terminal. So all of these three are meeting this one terminal. You could use a stud terminal, but I'm kind of double dipping, and I'm using this stud as not only a 12 volt bus bar, but I'm using it to also be the mega fuse for the inverter. So why do you need a mega fuse? So what's happening here now is the power is coming in on your solar panel, and then your power is also being run to your 12 volt devices that you're operating, and then power is also going to the battery. And the best way that I can explain this is your inverter it needs a lot of juice to convert 12 volts to 2,000 watts. So it's going to need that current, and you need to make sure that that current can flow as easily as possible. So kind of think of the gauge or the thickness of your cables like a water pipe. And the bigger the water pipe, the more flow you can have, the more amperage you can have, and the wire is not going to heat up and your system's going to run more efficiently. For example, if we had these little wires here, these are like 18 gauge or 20 gauge. These wires would get extremely hot, if not possibly melt, if we were trying to pull that much current that was needed to power this inverter. So that's why you're seeing two different size wires. The mega fuse is because we need to protect the amount of flow that's coming into this inverter. So if this inverter was to run away and short or something like that, we have a way to break the flow of electricity into the inverter so we don't damage the rest of our system, or in fact the battery. So if this fails, the only thing that will happen is it will just break the circuit for the inverter, but the rest of our system will be okay. Now, that is why we have the mega fuse and we have the really thick cables going into our inverter. Because our inverter is powering our household plugs, one of which is the refrigerator that's directly plugged into here, and then one that is hardwired into the inverter, that is our outlet up here. So it's our 110 outlet, and we actually have an outlet and two USB ports. So that is the inverter setup. It's kind of how that works. The next place that our power is going to is we're going to branch off of that terminal. And remember, all of this terminal, this cable right here is coming from our battery. So we have our power cable coming from the battery through the disconnect and into this stud that we're distributing off of. So next we have our power going to our 12 volt accessories. And if you notice, we don't need the same size wire for our 12 volt accessories. Technically this is actually too big of a wire, but you really can't oversize wires for small voltage or amperage use appliances, because it's just gonna, it's very efficient, low resistance. Now there's a point. These cables that are very thick, especially this 2-watt cable, they're very expensive. So you're not gonna want to use big wires for everything, because it does get costly. But what you're looking at right now is this. Let me open it up. This is how we're distributing our 12 volt. See if I can get some more light in here. This is how we are powering the rest of the accessories in our van. So what we have here is we have positive terminals going out, and then we have our negative terminals at the bottom. So those are all the black wires are coming from this ground or negative over here. That's how we're doing the van. Because in a van you really have a floating ground. You can't, you're not attaching a ground wire to the earth, obviously, because you're moving. Same thing as a boat system. So you want everything to come back to the negative side of your battery to close that loop. So everything that's down here on this negative bar is going to be ending up right here. So that's where that's coming from. Next, what we have is we have each one of our individual accessories that we're using. One of these is our puck lighting for the ceiling, which is up there. We have our diesel heater. We have our rear cargo lights, and then additional accessories that we want to use. Now what I've done is I've gone ahead and I've pre-wired every single terminal that I'm going to use. And then as we come down here, we have all that power routed to the top of our fuse block. So if we open our fuse block, You can see right now, although we have all these options, we're only using what the fuses are in here. Now, what's nice about this setup is if you pre-do this, not only does it look really nice, but when you want to add something in the future, you don't have to add a whole nother system. You just put a fuse in, and then down here, all these red wires behind this panel, you can just take one and put a fuse in and then add it to your accessory, and it's really easy to do that. Now if you're looking here, each one of these fuses is a different amp fuse. So we get a 10, 15, and those are going to be depending on how much how much protection you need for the amount of power your device is using. So the diesel heater has a standard thing from the manufacturer that's recommended. The puck lights, depending on how many you have, how long the run is, the gauge of wire, all that's going to tell you what you need to use for fuses. And you can find this online. It's really easy. Just type in the gauge of wire and what's the recommended fuse. Mostly the manufacturer of whatever device you buy, whether it's the light or the diesel heater, is going to tell you what they recommend that circuit to be fused at. So we'll go ahead and we'll cover this up. And if you notice, I use Blue Sea Systems for everything that I use because it's a great brand, but also I'm a very visual person, as you guys can see, and I like things to look the same, match, be very neat, and that's just kind of how I do things. But so final overview: battery, inverter, and as you notice, this case, we have everything kind of put in here for safety as well. We have our battery that is strapped down right here, so it's not going anywhere in the event of an accident. Our inverter is bolted to the floor, but we do have enough air gap, and we have a little, if you look down here, I don't know if you can see that, there's a louvered vent. So the fans pull air in, blow across the inverter, and then the louvered vent here where it can exhaust. And all of that is inside this nice compartment right here. So you can easily get access to it really quick if you need to. And then finally, you need to be able to monitor everything. So if something happens, everything's nice and neat. You're able to visually see if a fuse is blown, access it quickly. That's kind of the hardwired stuff. So your switches and controls, that's going to be this final part of the video before we're done. And that is where I come over here. So over here we have two devices. Actually we have three, one back there, and I'm going to show you about them. So we actually have three devices. We have our inverter on and off. So if we have this switch and we turn it on, we get a little beep. This one's directly connected to our fridge. So you can actually hear, I'm not sure if you can hear it, but the fridge is just turned on. And this is our controller for our voltage. So it's going to tell us the voltage of our battery currently. It's going to tell us how many amps are being drawn. It'll tell us estimated time that the battery will be fully drained, assuming that you're maintaining that same current draw. And then we got a visual display, and I'm not sure how good that's coming through on this GoPro. We have how many amp hours you have left. The way you want to set your amp hours is essentially what you want to do is run your battery down to 0 or fully charge your battery. And once your battery's fully charged, you can do a manual reset on this, and that will capture wherever it'll reset this to, so that it'll be at 100 or 200 amp hours, whatever battery you have. Then last but not least, we have our diesel heater. Now, we went with the fun Chinese diesel heater, which, to be honest, I mean, it works great. It's a little chintzy as far as the controller and stuff goes, but it works. It blows out hot heat, and it's extremely cheap. So in the event that it did break, you just buy another one. They're really cheap. But what I'm doing is I'm now going to be, not in this video, but these, you want to have all your controls in one location so you can just visually glance at them and check your system when you need to. I'm going to turn this off before I forget. So what I've decided to do is, if you open this up, you can see all these stickers. And that's because I have, this is where I plan to mount everything. So I've got a fan speed control, I've got a diesel heater control, the battery monitor, which we just saw, and the inverter remote. And so those will all be mounted in a custom panel here. And what's nice is you can pull this down, access it, but then at nighttime, when you want everything to be nice and dark, you can just shut that. Got a nice soft close. And all those LED lights, because this stays on when it's charging. All right, so that was a pretty in-depth video on the power system of this van, but I hope walking through that, show you where all the wires go and how a system is set up, will help you on your van build. Hope to see you guys in the next video, and I'll talk to you soon.